Materials required include Romex NM-B cable, typically 14/2 or 12/2 American wire gauge, a drill with a 1/2 inch spade bit, fish tape or a pull line, electrical outlet boxes and wall plates, cable staples, wire strippers, and electrical tape. Firstly, determine the cable route. Find the cable route from the cable entry point, which is usually near the electrical panel, to the desired outlet locations. Identify any obstacles such as walls, studs, or ceilings that the cable will need to pass through. Secondly, drill holes. Use the drill to create 1/2 inch holes for the cable entry and exit points. Drill holes through any studs or walls that the cable will pass through. Thirdly, run fish tape. Feed a fish tape or pull line through the hole at the cable entry point. Guide the tape or line through the holes in the studs and walls until it reaches the desired outlet location. Fourthly, pull the cable. Attach the cable to the end of the fish tape or pull line. Use the tape or line to carefully pull the cable through the holes, ensuring that the cable is taut and secure. Fifthly, staple and secure the cable. Staple the cable to the studs or walls using cable staples. Keep the cable at least 1 inch away from other electrical wires. Sixthly, install outlet boxes. Install electrical outlet boxes at the desired locations. Use screws to secure the boxes to the studs. Seventhly, cut and strip the cable. Measure and cut the cable to the appropriate length for each outlet. Strip about 1/2 inch of insulation from the outer cable jacket and each conductor. Eighthly, connect the cable to the outlet. Insert the cable into the outlet box and connect the conductors to the appropriate terminals on the outlet. Tighten the terminal screws securely. Ninthly, install wall plates. Install wall plates over the outlets to cover the wires and provide a finished look. Regarding a cheaper installation and wiring method, if a low voltage panel is not desired, consider these alternatives. 1. Use a RG6 coaxial cable which has 75 ohms. This cable is commonly used for cable television and is more cost-effective than Romex. 2. Use a wall-mounted distribution box. This box can be installed near the cable entry point and used to connect multiple cables to a single source. 3. Run the cables along baseboards or moldings. This method is less labor-intensive and can help conceal the cables. 4. Use self-adhesive cable clips. These clips can be attached to the walls or baseboards to secure the cables without drilling. Always adhere to local electrical codes and regulations when installing electrical wiring. Regarding the use of Romex cable, it is commonly available in 14/2 and 12/2 American wire gauge sizes. The first number indicates the wire gauge and the second number indicates the number of current carrying conductors within the cable. For example, 14/2 has 14 American wire gauge wires and 2 insulated conductors plus a bare ground wire. Typical applications for 14/2 are lighting circuits and general use receptacles on a 15 amp circuit breaker. 12/2 is typically used for 20 amp circuits such as those for kitchen receptacles or other high load appliances. When choosing the appropriate wire gauge, it's critical to consider the load that the circuit will carry and the applicable electrical codes. Using an undersized wire gauge can lead to overheating and potentially a fire hazard. The drill with a 1/2 inch spade bit is used to create holes through which the cable will pass. It's important to select a spade bit that is the appropriate size to allow the cable to pass through easily without damaging the insulation. When drilling holes, be careful not to drill into existing wiring, plumbing, or other hidden objects within the walls or ceilings. Fish tape or a pull line is an essential tool for pulling cable through walls and ceilings. Fish tape is typically made of steel or fiberglass and is flexible enough to navigate around obstacles. A pull line is usually a strong nylon or polyester rope. Attach the cable securely to the fish tape or pull line using electrical tape. Wrap the tape tightly to ensure that the cable does not detach during the pulling process. Electrical outlet boxes are used to house the electrical connections for outlets, switches, and other devices. They are typically made of plastic or metal and come in various sizes and shapes. Choose the appropriate size and type of outlet box for the intended application. Wall plates are used to cover the outlet boxes and provide a finished look. They are typically made of plastic or metal and come in a variety of colors and styles. Select wall plates that match the decor of the room. Cable staples are used to secure the cable to the studs or walls. They are typically made of metal or plastic and come in various sizes. Use the appropriate size staple for the cable being installed. Drive the staples in carefully to avoid damaging the cable insulation. Wire strippers are used to remove the insulation from the wires without damaging the conductors. They come in various styles, including manual and automatic. Use the appropriate size stripping notch for the wire being stripped. Electrical tape is used to insulate electrical connections and protect them from moisture and corrosion. It is typically made of vinyl or rubber and comes in a variety of colors. Use electrical tape that is listed for electrical use. When planning the cable route, it's important to consider the location of existing wiring, plumbing, and other utilities. Avoid running cable in areas where it may be damaged or exposed to moisture. When drilling holes, be careful not to drill into load-bearing walls or structural members. Consult with a qualified professional if you are unsure about the structural integrity of the building. When pulling cable, be careful not to kink or twist the cable. This can damage the insulation and reduce the cable's current carrying capacity. When stapling cable, be careful not to over-tighten the staples. This can damage the insulation and reduce the cable's current carrying capacity. When connecting wires to outlets, be sure to make a good electrical connection. A loose connection can cause overheating and potentially a fire hazard. When installing wall plates, be sure to tighten the screws securely. Loose screws can cause the wall plate to become loose and potentially fall off. Regarding our G6 coaxial cable, it is commonly used for cable television and internet connections. It has a 75 ohms impedance and is designed to transmit high-frequency signals. Our G6 cable is typically less expensive than Romex cable, but it is not suitable for powering electrical devices. A wall-mounted distribution box is used to connect multiple cables to a single source. It is typically used in applications where there are multiple cable, television, or internet connections. Running cables along baseboards or moldings is a less labor-intensive way to conceal the cables. It is a good option for homeowners who want to avoid cutting into walls or ceilings. Self-adhesive cable clips can be attached to walls or baseboards to secure the cables without drilling. They are a good option for renters who want to avoid damaging the walls. When installing electrical wiring, it's important to adhere to all applicable local electrical codes and regulations. These codes and regulations are designed to protect people and property from electrical hazards. Consult with a qualified electrician if you have any questions about electrical codes or regulations. The National Electrical Code, NEC, provides comprehensive guidelines for electrical installations. The NEC is updated every 3 years and is adopted by many states and local jurisdictions. Some key sections of the NEC relevant to residential wiring include Article 210.8, which covers ground fault circuit interrupter, GFCI protection, Article 250.52, which covers grounding electrodes, Article 300.14, which covers the length of free conductors, outlets, and switch points, Article 310.15, which covers ampacity of conductors, and Article 314, which covers junction and pull boxes. Always consult the latest edition of the NEC and local amendments for specific requirements. It is crucial to properly size circuit breakers to protect wiring. Overcurrent protection devices like circuit breakers and fuses are designed to interrupt the circuit when the current exceeds the conductor's ampacity, preventing overheating and potential fires. For example, a 14 American wire gauge copper wire typically has an ampacity of 15 amps and should be protected by a 15 amp circuit breaker. A 12 American wire gauge copper wire typically has an ampacity of 20 amps and should be protected by a 20 amp circuit breaker. It is important to note that these ampacities are based on specific conditions, and directing factors may apply depending on the installation. When working with electricity, always take safety precautions. Firstly, turn off the power to the circuit before working on any wiring. Secondly, use insulated tools to avoid electric shock. Thirdly, wear safety glasses to protect your eyes from debris. Fourthly, test the circuit with a voltage tester to ensure that the power is off. Fifthly, never work on electrical wiring in wet or damp conditions. Sixthly, if you are not comfortable working with electricity, hire a qualified electrician. Electrical wiring can be dangerous if not done properly. Always take the necessary precautions to protect yourself and others from electrical hazards. When connecting wires, use appropriate wire connectors such as wire nuts or crimp connectors. Make sure the connectors are properly sized for the wire gauge and number of conductors. Twist the wires together tightly before applying the connector. After applying the connector, give the wires a gentle tug to ensure that they are securely connected. When installing outlets and switches, be sure to follow the manufacturer's instructions. Different types of outlets and switches have different wiring configurations. Make sure you understand the wiring diagram before making any connections. Double check all connections before restoring power to the circuit. A wiring mistake can create a short circuit or ground fault, which can be dangerous. Use a multimeter to test the continuity and voltage of the circuit before restoring power. If you are not sure how to use a multimeter, consult with a qualified electrician. Consider using arc fault circuit interrupters of size in addition to ground fault circuit interrupters, GFCIs. SIs protect against arcing faults, which can cause fires. GFCIs protect against ground faults, which can cause electric shock. SIs are typically required in bedrooms and other areas where arcing faults are more likely to occur. GFCIs are typically required in bathrooms, kitchens, and other areas where water is present. The 2008 National Electrical Code, Section 210.12 requires SIs in dwelling units and bedrooms, family rooms, living rooms, parlors, libraries, dens, sunrooms, recreation rooms, closets, hallways, or similar rooms or areas. Understanding voltage drop is essential to ensure proper operation of electrical equipment. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run slower, and other equipment to malfunction. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To calculate voltage drop, use the following formula: voltage drop equals 2 times the length of the conductor in feet times the current in amps times the resistance of the conductor in ohms per foot divided by 1000. Choose the appropriate wire gauge to minimize voltage drop. Larger wire gauges have lower resistance and therefore less voltage drop. When running long circuits, consider using a larger wire gauge to compensate for voltage drop. Always consult the NEC for specific requirements regarding voltage drop. Proper grounding is critical for electrical safety. Grounding provides a lower impedance path for fault current to flow back to the source, which trips the circuit breaker and energizes the circuit. Grounding also helps to stabilize the voltage and reduce electrical noise. The NEC requires that all electrical equipment be properly grounded. The grounding system typically consists of a grounding electrode such as a ground rod or water pipe, a grounding electrode conductor, and equipment grounding conductors. Ensure that all grounding connections are tight and corrosion-free. The NEC provides detailed requirements for grounding electrical systems. Proper bonding is also important for electrical safety. Bonding is the process of connecting all metal parts of an electrical system together to create a continuous electrical path. Bonding helps to ensure that all metal parts are at the same potential, which reduces the risk of electric shock. The NEC requires that all metal parts of an electrical system be properly bonded. Bonding is typically accomplished by using bonding jumpers, which are short lengths of wire that connect metal parts together. Ensure that all bonding connections are tight and corrosion-free. The NEC provides detailed requirements for bonding electrical systems. When running cable through metal studs, use grommets to protect the cable insulation. Metal studs can have sharp edges that can damage the cable insulation, which can create a short circuit or ground fault. Grommets are small plastic or rubber inserts that fit into the holes in the metal studs and provide a smooth surface for the cable to pass through. Use the appropriate size grommet for the cable being installed. When running cable through walls or ceilings, be sure to maintain proper clearances from heat sources such as recessed lighting fixtures and chimneys. The NEC provides specific requirements for clearances from heat sources. Failure to maintain proper clearances can cause the cable insulation to overheat and potentially cause a fire. When installing recessed lighting fixtures, use recessed lighting fixtures that are IC rated. IC rated fixtures are designed to be installed in direct contact with insulation. Non-IC rated fixtures require a minimum clearance from insulation, which can be difficult to maintain in some situations. Always follow the manufacturer's instructions when installing recessed lighting fixtures. When working with aluminum wiring, use special connectors and antioxidants. Aluminum wiring is more susceptible to corrosion than copper wiring. Corrosion can create a high resistance connection, which can cause overheating and potentially a fire. Use connectors that are specifically designed for use with aluminum wiring. Apply an antioxidant compound to the aluminum wire before making the connection. The antioxidant compound helps to prevent corrosion. Always follow the manufacturer's instructions when working with aluminum wiring. Consider using a whole house surge protector to protect your electrical equipment from power surges. Power surges can damage sensitive electronic equipment such as computers, televisions, and appliances. A whole house surge protector is installed at the electrical panel and protects all of the circuits in the house from power surges. Use a surge protector that is listed by a nationally recognized testing laboratory. Always follow the manufacturer's instructions when installing a whole house surge protector. When replacing an existing electrical device, be sure to use a device that is rated for the voltage and amperage of the circuit. Using a device that is not properly rated can create a safety hazard. Check the rating of the existing device before replacing it. If you are not sure what the rating of the device is, consult with a qualified electrician. When working with electrical wiring, always be aware of the potential hazards and take the necessary precautions to protect yourself and others. Electricity can be dangerous if not handled properly. If you are not comfortable working with electricity, hire a qualified electrician. Always remember to prioritize safety when working with electrical wiring. A thorough understanding of electrical principles, codes, and best practices is essential for ensuring a safe and reliable electrical system.